Let's say you have to print out a statement 100 number of times. What are you gonna do? Are you going to write that statement 100 times? Of course not. We are going to use the looping statements in Java to do this. In this chapter, we are going to dive into the concept of the looping statements, which are going to help you perform repetitive tasks very easily and efficiently, and with full control to define how that looping condition is gonna work. We'll explore different types of looping statements which we can use in regular day-to-day programs. The classic for loop, which we can use if we know how many times the block of code needs to be executed or repeated. The while loop, this is where the number of repetitions depends on a conditional statement. And then we have a variation of while, that is a do while loop. This makes sure that the block of code is executed at least, and based on that condition, again, it is going to repeat that block of code. We also have enhanced for loop, which is a variation of for loop, and this offers much cleaner way to work with arrays and collections. We'll also learn how to break or control the loop's behavior using the break and the continue statements. By the end of this chapter, you will be able to automate repetitive tasks, make your codes shorter and smarter, write flexible code that responds to different conditions. Let's get into it, shall we? Looping statements in Java allow a block of code to be executed n number of times based on a specific condition. Loops are essential concept in any programming language. They are going to help you automate a lot of repetitive tasks, and each time that block of code runs, that is at each iteration, it is going to evaluate the condition, and based on that condition, it is going to keep repeating the task or it is going to stop doing that. Why do we use loops? So instead of writing repetitive code, loops allow you to write a block of code once and execute it multiple times. Loops are used in automating repetitive tasks like processing an element in an array, reading input till a specific condition is met, or performing a single mathematical operations multiple times. Looping structures allow you to handle both finite and infinite number of repetitions based on the dynamic condition. Let's have a look at types of looping statements. There are primarily 4 looping statements in Java: the for, the while, the do while, and the for each. Let's start with the for loop. The for loop is a control structure that is going to help you repeat a block of code based on the number of times that is defined in the for condition. It is typically used when the number of iterations is known beforehand. The for loop has 3 components. The first one is the initialization. This is where you initialize the value for the counter. Let's say we have created a counter I and we have assigned it a value of 0. The next component would be the condition itself. This loop will execute as long as that condition is met to be true. And the third one is the update. This is where the value of counter is either incremented or decremented. So it has to change that value of the counter so that after a point, and the second component, that is the condition, that evaluates to false, and that's when the for loop exits. So the update part is also very important. So this is how you define the syntax for it. In this example, the loop starts at I is equal to 0 and the condition is I is less than 5 and I plus plus. So this is going to print out this statement. Once it's done that, it is going to increment the value of I, so the value of I becomes 1, and similarly in the next iteration the value of I becomes 2, and in this way it will print the numbers from 0 to 4. Because the value of I is starting at 0, so the index is starting here at 0. That is why it is going to print out the value from 0 to 4, because when the value of I is 5 here, this condition here is meant to be false. That's when the control moves out of this for loop. Then we have the while loop. This is another control structure which is used to repeatedly execute a block of code as long as the given condition is true. Now the condition is defined in the first step itself, that is while condition. While the condition is true, execute the block of code, else exit the control from the while block of code. In this place again, we have to make sure that there is an increment happening, else the loop will just run infinite number of times. The while loop is often used when the number of iterations is dependent on dynamic conditions that may change during the execution of program. So in this case, we have defined a separate counter, int I is equal to 0. While I is less than 5, we are doing the same thing which we did in the for loop. it's just a different way to do it. So while I is less than 5, print out the iteration and I plus plus. Now this is going to print out and then it's going to increment the value of I. So in the first iteration, it's going to be I is equal to 1. Second iteration, I is equal to 2. And this is also going to print out all of the values from 0 to 4. Now let's have a look at the do while loop. This is a slight variation of the while loop. It works in one small different way. In the while loop, the condition is checked in the first step itself, and based on the condition, it is going to execute that block of code. Whereas in do while, the condition is checked in the last step, and the block of code defined earlier executes at least once. As you see, int I is equal to 0. It is going to print out the value of I, iteration I, and it is going to increment that value. And in the last step, it is going to evaluate that condition, that if I is less than 5. So this code executes this statement at least once, and based on this condition, it is going to decide if this code needs to be executed again in iterations till this condition is false. So that is how the do while condition works. Then we have enhanced for loop. This is a specific version of for loop, and this is used much more while working with arrays and collections. This loop simplifies the process of iterating over elements without needing an index value. So here, let's say we have this array defined. We will look at what an array is. We can write it simply without a counter variable. So int num. So this is like a temporary variable which for creates, int num, and it is going to traverse through all of the elements present in the numbers list. Then it is going to print out each number. So that is how the for condition works. Then we have infinite loop. You may encounter something called an infinite loop. That is when your conditions or when your counters are not defined correctly. Your loop may run into an infinite loop. That is, it may never terminate on its own. It will keep executing. So you need to be careful while working with such loops because this may end up crashing your program. So be careful and mindful about it. And let's quickly go through the loop types. That is, we have a for loop, which is the most simplest form of statement, and it executes the block of code a specific number of times. Then we have the while loop. This executes a block of code based on a condition, and the condition is checked in the first step itself. Then we have do while. This is going to run the block of code at least once, and the condition is checked at the last step, and based on the condition, it is going to repeat that block of code. Then we have enhanced for loop. This is a version of for loop which is more useful while working with arrays and collections of elements and objects. Let's quickly go through these loop control statements. The break statement is used to exit a loop entirely. When the code encounters a break keyword, it is going to move that control from that block to the previous block, and it is going to then execute the next set of statements after the loop. We also have a continue keyword. This is going to help us skip that particular iteration based on a condition. So let's say based on a value, you don't want to execute that block of code. So you just write continue and define that condition, and then it is going to simply skip out that iteration. It will move to the next iteration. That is how the continue keyword works here. Let's quickly go through an code example to discuss the looping statements in Java. The first one is the for loop. So for here, first let's define a simple for loop. So this is how you're going to define a for loop. We have a counter variable. I is equal to 0, I is less than 5, and I plus plus. And here under this, we can simply write the print statement to print out the iteration. Let's close this. And similarly, let's work on the while loop as well. Here, let's first define int I is equal to 0. You might be wondering, we have defined int I 2 times. This is because this int I is specific to this for block, whereas this I is specific to this class. So that's how you're able to write it out 2 times. And let's say we want to evaluate the condition while I is less than 5. So this is the condition we have defined here, and based on that, we can write 2 statements here. One would be the print statement that would be printing out the iteration, and here we also need to increment the value of I, so that value of I moves from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. And when it reaches 5, that's when this condition is going to be false, and that's when the while loop stops executing. Similarly, let's do one for the do while. We have already seen the difference between while and do while. While is going to evaluate the condition in the first step. The do while is going to evaluate the condition in the last step. So here we can simply write a do while statement here. So do print out the iteration value, then increment the j value, all while the condition is j is less than 5. Let's save the program and see the output for the first 3 looping statements. So you see here iteration 0 to 4, iteration 0 to 4, iteration 0 to 4. So they are all working as expected. Because this condition is I is less than 5, I is less than 5, so it is going to only work till 4. Now let's quickly go through the enhanced for loop. For that we will define an array here of numbers. That is an integer type. So now if we want to print out these elements using for loop, you can use the traditional for loop as well to work on this, but we have an enhanced for loop to work on this thing. So here we have for, this is like a temporary counter variable, and this is the actual array, and this is going to print out the num, that is the counter variable. In each iteration it is going to read the value from this array. Let's save the program and run. You see this is going to print out the 1 2 3 4 5. So at one iteration it is going to print out one value. So that is how enhanced for loop works. Similarly, let's see how break statement works here. So we have defined a simple for loop with int k as a counter variable, and inside the for loop we are checking a condition. Like let's say in an iteration, if the value of k is equal to 3, then it needs to perform a break. That is, it needs to move the control out of the for loop altogether. So save the program and run. You see now here you see the value is 0 1 2, and when after the incrementing of k plus plus, when the value of k is equal to 3, it is going to perform a break. So that is, it is going to quit performing the repetition. It is going to move that control out of the for block, and that's why the for block here has stopped executing. On the other side, let's follow the same process, and instead of break, let's just use a continue statement here. I've done the similar thing. I've just created another counter variable. L is less than 5, L plus plus is if L is equal to 2, then continue. Now this is going to just skip the iteration where L is equal to 2. Other iterations are going to run fine. So if you see 0 1, so when the value of L is equal to 2, it has skipped printing out that value. It has moved to the next iteration, that is value is equal to 3 and value is equal to 4. Let's quickly go through how an infinite loop can happen unexpectedly. So you see, while condition is equal to true, print out, this is an infinite loop. So the condition here is not changing. So this is always going to stay true. So if we run the program, it is going to keep printing it. This is an infinite loop. So until and unless I stop the program here, this is going to keep printing it. So that is the danger of infinite loop. So be very careful while safeguarding the conditions in an loop statement. And that's about the code example for the looping statements in Java. Let's quickly go through some of the best practices and tips while working with looping statements in Java so that your code stays efficient and error-free. Use the right loop for your problem statement. That is, Java has different looping statements: the for, the while, the do while, and the for each. So understand when and where to use each one of them. You can use the for loop when you know beforehand how many times the number of loop needs to be executed exactly. Then we have while loop. You can use this when the number of iterations is unknown, but you know that there is a condition which needs to be met. So you can define that condition in a while loop. And then you have the do while loops. This is where you want to make sure that your loop runs at least once, and then you define a condition, and based on that condition the code can decide to repeat the code. Avoid infinite loops, like we discussed, it could crash your program. So be very careful while defining the conditions and the counters while working with loops so that your code does not go into an infinite loop. For that, make sure your conditions are set properly, that your conditions move to the false state at the right time, and double check your counters if they are being updated properly or not. Minimize the use of break and continue continue. They are useful, but try minimizing their use. They can cause your code to be much harder to read and understand and debug. It's always better to write loops with clear and easy to understand conditions. Avoid nested loops whenever they are possible. You can use nested loops to work on different statements, but they definitely can increase the complexity of your program and slow down your Java program, especially when both of the loops run in multiple iterations. Always ask yourself if there is a way to simplify the loop and simplify the logic itself. Nested loops are like a loop inside loop, so they are going to multiply the iterations. So it is going to affect the performance. So try refactoring or flattening out the code so that your conditions are simple and easy to run. Use enhanced for loops while working with arrays and collections. The enhanced for loop is cleaner and easy to work with while iterating the elements present in a collection or a list. It automatically handles the indexing part and is less error prone. Again, to reiterate, keep loops simple and maintainable. Loops that are too complex or contain too much of code can be hard to follow and maintain. Keep the logic inside the loops as simple as it can. If you need to perform multiple tasks in a loop, consider moving them into methods. As we'll see the advantage the methods bring to Java. Optimize loop conditions, that is, each time the iteration runs, the condition is evaluated. So try to make sure that your conditions are simple and the code executing inside the block is also simple. It does not contain heavy operations. Avoid placing unnecessary computations or method calls inside the loop conditions. Be careful with loop indexes. Ensure that you don't go out of the bounds, that is the limit, else it will give you an error that the index is out of the bounds and it could crash your program. And make sure you're testing your loops carefully. Since loops can run fewer or many number of times, look at the infinite loops, look at the bounds, look at the conditions, look at the increment decrement operations which is happening. So test it out thoroughly so that you don't encounter any additional errors while working with them. Choosing the right type of loop for the task is going to help you minimize the complexity. Avoid unnecessary errors. Proper use of loops and control statements can help you enhance the performance and the clarity of your code. And that's about this chapter. To wrap up, in this chapter we understood the concept of looping statements in Java. They are going to help you repeat a block of code based on the condition or based on the number. We discussed the for loop for simple iterations, where the number of iterations themselves is known beforehand. Then we discussed the while loop, where the condition is checked in the first step itself, and based on that condition the block of code is executed. And then you also need to make sure you have the increment and the decrement operation happening. Then we had the do while looping. This is where the condition is checked at the last step. The do while loops make sure that the block of code is executed at least once. Then we went through the enhanced for loop, which is a much better option of a for loop while working with arrays and collections. We also discussed the control flow statements, that is the break and the continue, which are going to help you control the flow of your loops. It is either going to help you jump out of the loop or skip that particular iteration. In the next chapter we will be spending some more time understanding the break and the continue statement and how they influence the control inside the loops and the methods, and how to use them effectively without overcomplicating your code. I'm Venkatesh Mudaliar. Till I see you again in the next one. Cheers.